So basically, this is all the math review before we get into calculus. So let me actually give you the overview of what we're going to do in calculus. So there are two big questions in calculus. There are two big questions in calculus. That is, if I have a graph, how do I find out how fast the value of this function is changing? And it turns out this value, how fast it's changing, that's going to be the same as the slope of the line that is tangent or touching my graph. This value is called the derivative. And it's going to be the focus for the first half of the semester, and that's the first big question in calculus. The other one is if I have a graph of a function, how do I find the area under the graph of this function, or the area between the graph of this function and the x-axis? This thing is called the integral. And it's going to be the focus for the second half of the course. Now, to actually answer these two questions, there are one fundamental concept that we have to learn, and that concept is called the limit. To understand limit, let me actually just talk about the example that we have down here. Let's say my function is f of x equal to x minus 2 over x minus 2. Okay? The first thing you might be wondering is, wait a minute, x minus 2 over x minus 2, don't they just cancel out and equal to 1? Well, let's see. If I want to compute f of 5, that should be f of 5. If I just plug 5 in, so I'm going to get 5 minus 2 over 5 minus 2, and I get 3 over 3. So indeed, they cancel out and give me a 1. Okay, so that's not bad. Let's try the next one, f of 2. F of 2, I'm going to get 2 minus 2 over 2 minus 2, and I get 0 over 0. And now I'm in trouble, because now I get a division by 0, I get 0 over 0. So this is indeterminate form. So what it kind of means is it just doesn't exist. So there's no way we can deal with this. So that means the function is actually undefined. There is no value. When x equal to 2, I'm just not able to find what 2 over 2 is. And that's exactly what happened to this function. X minus 2 over x minus 2, it cancels out and give me a value of 1 everywhere, except one little value when x equal to 2. So this guy is just 1 everywhere, with one tiny little exception when x equal to 2. And that's a real pity, because this is what the graph looks like. It equals to 1 everywhere. Everywhere we talk about it equal to 1, but when x equal to 2, there's a hole in the graph, and it just means I'm not able to find the function the value of this function. So, well, some guy has found a way to deal with this, and the way we can deal with this is to use what we call the limit. So the idea behind the limit is this. If you look at my range function here, sure, it exists everywhere except 2, but so I cannot talk about f of 2 because it's not defined. However, if you look close enough, the function is 1 everywhere, so why don't we just somehow call that f of 2 is equal to 1, to that somehow thing is called the limit. The limit will have several components. The usual notation is the limit when x goes to some constant of a function. the limit will usually look like this. There will be x go to a y, go to or a variable, go to some value of a certain function. What this is basically asking me is, what is the value? What is the value of my function when x approach the constant? What is what? What is the value for my function when the x approach this constant value? And you can kind of see this terminology kind of solve the dilemma that we have earlier. What is the value for f of x when x approach 2? Well, you can see from the graph, even though f of 2 doesn't exist, but when x approach 2, its value remains at 1 and it remains unchanged when x goes to 2. So this whole limit is going to equal to 1. So in a way, the limit thing is going to help us deal with the case when my function is undefined, but I want to find the value of the function at that point. I want to very much find f of 2, but it's just not defined. So I do the next best thing, which is what is the value of f when my x approach 2? And that's exactly what happens in this graph.